Good. Well, hey, what a great day, huh? I was up at 5. I haven't been getting up early for a while, for years. I got up early for decades and decades and decades. So I haven't been getting up early. Like early for me is 6. So today I got up at 5, and I forgot how nice it is to be up early. Get so much done. And I was over the hill by 7 something and teed off a little after 8. I just had such a good day, man. It was a good day.
Are you tired now?
$140. No, I'm not tired. But you know, I'm not tired. I'm kind of energized. I got you. I wrote you here, Ben. I got your text.
Thank you.
But I did have a Perrier infused with matcha. Matcha is pretty good stuff. I like it better than caffeine, or I'm not sure if it has caffeine in it or whatever it has, but it took away any shred of tiredness I might have had. It's always fun. And I was just rummaging through the back of my car and came across this book again, which I read all the time. So I'm gonna you have to suffer a few paragraphs of this. And I think I'll read the beginning of the second agreement. If any of you don't remember this book, The Four Agreements, the 4 agreements are: be impeccable with your word, don't take anything personally, don't make any assumptions, and try to do the best you can in whatever you do. So the second agreement, don't take anything personally. The next 3 agreements are really born from the first agreement. The second agreement is don't take anything personally. Whatever happens around you, don't take it personally. Using an earlier example, if I see you on the street and I say, hey, you are so stupid, you should just cold cock me. Without knowing you, it's not about you, it's about me. If you take it personally, then perhaps you believe you're stupid. Maybe you think to yourself, how does he know? Is he clairvoyant? Or can everybody see how stupid I am? You take it personally because you agree with whatever was said. As soon as you agree, the poison goes through you, and you are trapped in the dream of hell. What causes you to be trapped is what we call personal importance. Personal importance, or taking things personally, is the maximum expression of selfishness because we make the assumption that everything is about me. Well, I may not be much, but I'm all I think about. I added that. During the period of our education or our domestication, we learn to take everything personally. We think we are responsible for everything. Me, always me. Nothing other people do is because of you. I believe this on a cellular level. My mind wants to trick me all the time. It wants to tell me that none. Nothing other people do is because of you. It's because of themselves. All people live in their own dream, in their own mind. They are in a completely different world from the one we live in. When we take something personally, we make the assumption that they know what is in our world, and we try to impose our world on their world. Even when the situation seems so personal, even if others insult you directly, it has nothing to do with you. What they say, what they do, and the opinions they give are according to the agreements that they have in their own minds. Their point of view comes from all the programming they received during domestication, which is part of the first chapter. It talks about how we get domesticated and our belief system gets domesticated. If someone gives you an opinion and says, hey, you look so fat, don't take it personally, because the truth is that this person is dealing with his or her own feelings, beliefs, and opinions. That person tried to send poison to you. And if you take it personally, then you take that poison and it becomes yours. Taking things personally makes you easy prey for these predators, the black magicians. They can hook you easily with one little opinion and feed you whatever poison they want. And because you take it personally, you eat it up. You eat all their emotional garbage. Now it becomes your garbage. And if you do not take it personally, you're immune in the middle of hell. Immunity to poison in the middle of hell is the gift of this agreement. Just keep reading that, but probably have other things we should do. Did I take roll? Just kidding. I knew I did. So Austin's here. Austin's here. Austin Bradley's here. How about Matthew? Matthew, did you get here? Matthew Aguinaga? Aguinaga? How about Adier Gallardo? No? See if they texted me. Told me that they were going to be something. Okay, let's do it. Oh, too bad. So did you see how small a space that he operates his operation on?
Yeah, it's just like a back
Yeah, it's just a
lot.
hole in the wall, right?
Yeah.
It's a back lot hole in the wall with room for some parking. I'm talking about Matt Shaw Construction, who's probably the second biggest guy in Santa Barbara. I mean, right now, there may be some other guys I don't know about, but KCI, John Canny, the guy that Robert works for, that was our foreman steel guru, excuse me, Matt Shaw, who lent us the stakes, Matt Shaw Construction. He won a couple of really big awards at the construction awards just 2 weeks ago that I went to. And I sat at his table. We were at the same table. Yeah, for some really killer projects, but yeah, we just got room for a few trucks and an office, a funk dog office for estimating, and runs a multi-million-dollar business. Wow. Out of there. There's money in concrete. I mean, these guys do, you know, that one I showed you on the beach. Remember on the beach at Sandyline Beach and all that framing and all that killer framing? Well, I'm sorry, that was next door. I never showed it to you guys in this class, but some of you that have the other class 110, that was like $1.5 million, man.
Whoa.
In concrete.
Whoa.
74 caissons, 74 columns, and they were finished 8 feet above ground. Anyway, and then you have KCI, and he's got his yard and offices are probably 10 times the size of Matt's, and he's got all kinds of, he's got really big equipment. He's got this big blower truck that blows gravel. It'll blow 3/4 about, it might even blow up to 2 inch, but I know it'll blow 3/4 gravel, and it'll blow it 100 yards. Wow. So it's for placing materials that they're hard to get to. So you just shoots them. I don't think everything goes, that's probably the full extent as far as it goes, but it's a pretty awesome machine. He's got a couple of big augers stuff too. He also lost a guy at his yard. He had a mishap 2 or 3 years ago, a guy who died. A piece of steel fell on him and killed him. It's dangerous business, construction. Did we take roll? Just kidding. No, we didn't. All right, here we go. Shrink that. Hey, shrink that. Why is that not shrunk? Huh. Weird. Wouldn't shrinking. Okay, let's have a safety meeting. Let's pretend that we're working and then it's been 5 days or so and we want to have a safety meeting. We need to have a safety meeting. We're all feeling antsy and unsafe. Let's have a safety meeting about falling objects. But before we do, gents, I think I'm on the one thing, right? I think I'm on just one switch, one of two, pretty sure.
Oh, yeah, you are. Okay.
Turn my water upside down on my pocket, and the lid wasn't on. Oh, this one. Oh, the delay one. Thought about this one. This is one of the older ones. I used to, my MO, and any of you that don't know what that means, it's short for modus operandi, which is Latin for method of operation. My typical MO is to print out 20 sheets and hand you all out a sheet. And then you hang onto the sheets, print this sheet printed. And then I have sheets up here for the test, so you can look at them and stuff like that. And at some point I thought, really? But these are some of the older sheets. That's the old Santa Barbara Contractors logo. Okay, I'll start it out. Prevent injuries from falling objects. Objects falling from above and striking people below have caused serious industrial injuries and account for a number of fatalities every year. Although the exact number of falling object injuries is difficult to determine, documents produced in several recent court cases suggest that the practice of high stacking materials and supplies poses a serious safety threat to those below. John?
Provide adequate warning. Workers or customers below depend on those working above for their safety. If you're going to be doing work overhead, warn those in the area either verbally or with signs, ropes or barricades. For those below, it's their responsibility to be aware of the work being done overhead and observe the warnings and barricades.
Okay, Angel.
Secure the load. If you be lifting a load to a high level, make sure the load is balanced and secured so it won't slip off. Restraints such as nylon strapping bands can be used to secure overhead goods. In some cases, merchandise to be stacked on top of racks can be shrink wrapped in plastic to provide stability and keep loose boxes and other items from falling. If using plastic wrap, remember that the plastic may stretch due to the high heat at the top of the racks and may cause the load to shift. Another safety precaution is to provide netting on stored items or restraint bars to keep the load in place. If placing a load on a scaffold or platform, make sure that there are guardrails or toe boards to prevent materials from falling off.
Louis, Daniel?
Moving a load. Never lift, lower, or swing the load over anyone's head. Block off areas where loads are being lifted or lowered. Have a spotter in the bending aisle where items might be pushed off racks or platforms during moving or stacking of materials. If possible, restrict these stacking and heavy moving operations to hours when fewer people are present.
Matthias?
Practice good housekeeping. Keep tools and other materials away from edges and off of railings or sills. Stack them on a flat surface, cross tie, or cover them if necessary to keep them in place. If you're working overhead, watch that you don't kick, throw, or sweep material off that could fall on anyone below.
And whenever there's a risk of falling objects at a work site, an employer is required to provide protection for workers and visitors to the site. Hard hats and safety shoes are examples of personal protection against falling objects. Okay, well, that's kind of common sense. Anybody have any comments or questions or anecdotes from their past where anything fell on them?
I had a TV on me
Did you really?
back when I worked audiovisual.
Oh, so that was like a new TV that was on a stack in a
It was
warehouse or
a-
something like that?
It was a 50-inch flat screen TV, and we had these mounts that we would roll around for it, and the guy I was working with didn't secure it properly. He was like trying to jimmy rig it, and it fell right down.
You said to do what rig it?
Jimmy rig it, or just like
Jury rig it.
yeah, he was just messing it up, and he was gonna duct tape it and do all kinds of weird stuff.
And it fell and it hit you in the head.
Fell
From,
right down.
did it- so, but how far did it fall from?
Oh, maybe a foot or something.
So
I was-
that's
I was
what
bending down.
happened.
Yeah, never the same again.
Well, from a foot, you were lucky it didn't fall off like 10-foot shelf
Oh, yeah.
in the head.
Yeah.
So if you're working high, just be aware of what's below you, right? And if you're working low, be aware of what's above you. And if there's people working above you, be aware of where they're working and stuff like that, because stuff happens. What was I gonna tell you about? Oh, shoot, it just went in my head and then it went right out.
We had this old coworker too that used to work audiovisual, and he fell off a ladder, and he's never the same ever again.
Ladders are dangerous.
Yeah.
They're dangerous things, but I had a job for Jim Messina. We were doing the spiral staircase. It was really fun. I've done a lot of work for Jimmy, and this was at his house or one of his houses at the time. And I laid out and designed the spiral staircase and had it made, and then we were putting the railing together. And I had a guy doing the up easing, a guy named D'Amato, James D'Amato. He's a really good French carpenter, a guy from New York. And an up easing that connected to a quarter turn. And in stair parts, when you do handrail systems, in stair parts, you connect parts, and there's a way of joining them with these hanger bolts, and make pitch blocks based on the angle of the pitch of the stairs, and it's really kind of fun stuff. But James dropped the quarter turn, which is a piece of wood molding, probably weighed about a pound, maybe a pound and a half of red oak, about maybe 8 by 9 L-shaped configuration, and it fell and it hit the Jim Messina on the head. It was such a bummer, because Jimmy was really bummed, and it was like, make sure you have a concussion, and yeah, so just be careful. He never should have been under James when he was working, for starters. So really, it's your responsibility to look below you, and it's your responsibility to look above you. And then just an anecdote from my past. I'm leaving a job site with Todd Law. He's a carpenter that works for me, and he's in front of me. And we cross onto the street in the job site. And as we walk from my customer's property onto the street, there's no sidewalk, I hear this noise, and then whap, I hear this big whap, and then I see this cable goes whap and hits the ground. So a cable maybe 3 inches in diameter, full of 50 million pairs of telephone wires, are being strung by Irish communication from pole to pole, and they don't have it tied up, and they let the damn thing go, and it falls, and it hits my guy, Todd Law, right on the top of his head and compresses his spine. And ultimately, like 5 surgeries, never really worked again. My workers' comp mod, he's not even on my dime. He's not on my customer's property, and it's not even done by my guys.
Here's a list of my top 3.
Some other guys, and yeah, my mod rate went up to 2.25. So does anybody know what that is? What I mean by that?
No.
Anybody know what a mod rate is? Okay, so if you are a contractor, you have workers' compensation insurance. Period. You are not operating legally as a contractor if you don't have workers' compensation insurance, a licensed contractor, unless you have a waiver filed with the CSLB saying you have 0 employees. As long as you have no employees, that's okay. You don't have to have workers' compensation insurance. But everybody's got workers' compensation insurance that has an employee. You should have it. You're supposed to have it. And everyone has a mod rate, has an X mod. And you start out, your X mod is 0. So your modification is 0. And let's just say at the time, I think I was paying for a journeyman carpenter over $21.99 an hour. I think it was a time where it was pretty high. It was like $48 on the 100. really high. I mean, it has skyrocketed and gone, it's gone way down, but I think it was around 48 bucks, right? So that means that for every $100 I pay my $21 an hour carpenter, every $100 I pay him, I have to pay $48 to my insurance company. I have to factor that into my costs. And if I'm selling this guy, I have to factor that into my cost. My sell is different than my cost, obviously, but that's part of my cost. And it's a pretty major part of the cost. If you think about it, 48% of 21 or whatever I was paying him, let's just say it was $24. Say I was paying him $24 an hour, which is probably about right. 48% is almost 50. That means for every 24 bucks I gave him, I had to give my workers' comp carrier 12. And that's just one person I had to give it to. So, and that's at a 0x mod, or I'm sorry, that's at a 1x mod. That's one. So 1x mod means that if everybody pays $48 on the 100, that's what I pay. My x mod went to 2.25, which means that at $48, I paid $108 on the 100. So for every $100 I paid my guy, I paid $108. And for every $24 I paid, I had to pay 2.25 times. I had to pay like 60 some odd bucks. Pay you 24 bucks, I got to pay the insurance company 60 bucks. It's so upside down, it almost put me out of business. And your experience modification is done by the insurance rating board in Sacramento or San Francisco or someplace like that, based on your claims. It's all actuarial stuff. So they just take the numbers of your claims. And then so Todd's claim was huge. It was just, it took my losses and just, it took years. And that my company told me that they would subrogate with Irish, a company that were responsible for dropping the cable. They would subrogate with them in the end, and I'd get money back, which never happened. So be careful.
Did you get your refund?
No,
For
I never got a refund. I never got a dime back. I just had to pay through the nose. So
Not for the fried things at your house?
I haven't submitted my claim yet. I'm waiting for the invoice from my HVAC guy. But
Okay.
I got to show you guys this. Did I show you this? I don't think I showed you this. I told you though. I told everybody the other day. But for the people in here, out there, and in here that I didn't tell, I had a high voltage surge on Sunday, Halloween, and it fried 5 of my appliances. Fried a coffee maker, 2 surge protectors, a sprinkler controller, and my wireless thermostat. So the wireless thermostat has been the most expensive. It's $280 for the part. And then I don't know what the labor is going to be for my HVAC guy, but the HVAC guy got me all fired up finally. The next morning it didn't work. It didn't actually work when he left. It just sounded like it would. So it showed me the thermostat, sounded like the fan came on, and that was it. And he left. He'd gone way too long anyway. And so the next morning I went in, my heater was supposed to be on. I left it heat on at 65. And the house would have gotten down to about 61. So I was going to keep it at 65. Anyway, no heater, no forced air unit, right? And then back and forth, all kinds of texts to him. And, finally, as a kind of a last ditch thing, I went down there, turned it on and off. Unplugged it, I mean, right? Unplugged it. I had the door off, right? Looking at the guts. If you ever looked at the guts of an FAU, there's a lot of stuff going on in there. And one thing that was really clear was that switch, and it was in the off position. It's like 1/2-inch letters, white on black, right? In the off position. And I'm looking at that switch thinking to myself, there's no way this should be off. And sure enough, turn it on and that heater worked like $1 million. Yeah, it's one of those one button pushes. And it's been my experience that when things go wrong, it's almost always the simple answer. It's almost always the simple, easy answer, or the first one that comes to mind. Oh, no, it couldn't be that simple. Like I couldn't get cable TV in the first RV park we went to. We got our RV and I asked the camp host, and he came over and I said, he goes, do he looked at me, he said, because it was just snow, right? Plug in the camp cable, just snow on my TV. And he looks at me, he says, is there a button? I don't know. Is there a button? And he starts feeling around behind my TV and the recess behind my TV, and he goes, aha. He pushes a button and it comes in clear as a bell. So it turns off the antenna, which doesn't allow the cable to happen. So it's become what's the word? An example, like a one button. Is it a one button fix then? Those are the kind of fixes you want. This was a one button fix.
That same thing happened to me today.
Really?
Yeah, we have this new environmental controller in our greenhouse.
Yeah.
And the electricians came and set it all up and wired it, so it should be good to go. And I'm trying to program it. Can't figure out how to turn the thing on. I'm on the phone with the electric company, the electricians that did all the wiring and everything. And I open up the unit. I've opened it up before, I didn't see anything. There's a little circuit breaker inside the unit that was set to off. Switched it on.
It's a one button fix, which in my experience, the simplest answers always.
Which is crazy. It's like, why doesn't the HVAC guy or the electricians? flip it
That's their
on?
job, man. I'm
Right.
paying these guys 100 and some an hour.
Yeah.
Because I didn't turn that thing off. And I didn't take the cover off and. But anyway, it's fixed. Who made it? Did anybody make it to Adier? Did you make it? No, Matthew Aguinaga, did you make it? No? Okay. Okay, just not here, big blanks. All right.
Rodney, I've got a question about the safety meeting. Can you hear me?
Week 11, you realize it's week 11?
Yeah, time flies.
Week 11,
Yeah.
after tonight, that's only 5 times we meet. 5 more times we meet. And one of those times will be our final, the last time. So there will really only be 4 meetings. We'll have a review the time before the final, so 3 before the review. So we really have 3 after. Time flies when you're having fun, huh?
Teach green building,
Say again, please.
teach green building next semester.
Screen building?
Green building.
Green building, yeah, I should.
Patrick's class.
That's, I don't know, Patrick's bailing on us. Okay, so last week, we went through linear and perimeter measurement. We didn't get to area measurement, did we?
No.
I don't think we did. Okay, so we're gonna do a review of area measurement. Check it out. Oh, there's nothing there. Oh, well. Back to the drawing board. So let's go down to our resources, to unit 16, I believe it is. Nope, unit. What happened? Area measurement. That's what I was just talking about, right?
Yeah.
Did I take roll? Okay, here we go. Here we go. I think there's a plus for this thing, isn't there? How did I get this to go bigger? So in this chapter, we're gonna learn about our objectives are to calculate the area of a square, the area of a rectangle, the area of a triangle, and we're going to calculate the area of an irregular shaped object, and we're going to convert square units of measure. So in unit 16, perimeter measurement, perimeter was defined as the distance around the outside of a polygon. Area is defined as the amount of surface within a polygon. Area is measured in square units, such as square inches, square feet, or square yards. Throughout the building process, the surface area of squares and rectangles must be calculated to determine material quantities, such as sheathing, siding, or roofing material. With the complexity of many architectural designs, the area of the irregular shapes must be measured for material quantities. With the complexity of many architectural designs, the area of irregular shapes must be measured for material quantities. And I'll show you any shape. Really. Oh, there's some shapes that are kind of tough. But certainly any circles, we haven't got to circles yet. These are rectangles and squares, but and triangles and was it not polyhedrons, but irregular shaped objects. So this is done by breaking them into squares, rectangles, and triangles, measuring them individually, and then adding them together to find the total. It's often necessary to divide an area into known shapes. Unlike squares and rectangles, it consists of 4 sides. A triangle is a polygon that's formed only by 3 sides. I guess, did anybody else just learn that? I hope not. Before calculating an area, all measurements must be expressed in the same unit. This doesn't say sometimes, it says all. So always and all, they gotta be the same unit. After an area measurement's been determined, square units of measure can then be converted from a unit to another. But you got, if you're doing square inches, everything's got to be square inches, square feet, square yards. You can't, and we've covered that in a second here. So here's an area of an 8-inch square. It's 64 inches, right? 8 times 8, one side times the other. Or in the case of a square, it's really a side squared. A 4-inch square is 16 inches, since 16 square inch in area. When calculating the area of a square containing denominant numbers, there are units combined to create a squared unit. So 8 inches times 8 inches is 64 square inches. And square, SQIN is a good abbreviation. I like the square with inches in it, and I'll show you on the board when I get to the board. I almost never write IN squared, IN with a little 2 like that, but it certainly is pretty obvious what it means. So the area of a rectangle is determined by multiplying the length of the width. Multiplying the length by the width and expressing the answer in square units. So a 5-inch by 16-inch rectangle is 80 square inches. When performing area calculations, all measurements must be expressed in the same unit. A rectangle measuring 15 inches by 2 feet would be calculated as either 15 inches times 24 inches, because you convert the 2 feet into 24 inches, or you could do it in feet, and that would be 1.25 feet times 2 feet, because 15 inches, 1 foot, 3 inches, 3 inches is a quarter of a foot, is 1 1/4 feet. And you should have learned that if you didn't know it in the about 2 units back, right? And to take 15 inches and turn it into feet, you just divide 12 into it. You put the 15 over 12. That means you divide 12 into 15, goes in 1 with 3 over 12 left over. 3 over 12 reduced is 1/4, and 1/4 as a decimal. 4 into 1 goes 0.25 times. So here's a triangle, and the area of a triangle is very easy. You just got to figure out which is the base and have it and multiply it times the height. And the inverse is also true. You can have the height and multiply it times the base. It does not matter. But in terms of the formula, it's half the base, half b times h, which is half the base times h. So
It's not
or you can multiply the base and the height and just take half of the whole thing. Yeah, all 3 things, right? So if you take half the base, that's 6 times 10 is 60. That's the answer. If you take half the height, 5 times the base, 5 times 12 is 60. That's the answer. If you take 12 and 10, if you multiply 12 times 10, that's 120, and then have it, that's 60. So all 3 ways of doing this are correct, and they all arrive at the same answer. And that's the key. Things are correct when they're the same answer. So it doesn't matter how you do that, but the formula they're using is, I've always had it as half the base times the height, but they've got it as half of the base times the height. Whatever you feel comfortable with, as long as you understand the concept, right? It's pretty simple. And so typically, you've got an odd shape, an irregular shape, but you break it out into, you got to break it into squares, rectangles, and triangles. So this is pretty easy, gabled in. You've got a triangle above a rectangle. So you've got the rectangle below, which is 8 times 24 to give you the area, which is 192 squares. And then you got 10 times 24 is 240, half of that's 120. So 120 and 192 is 312. Piece of cake, right? And it actually is a piece of cake in this case. In unit 15, linear measurement, the practice of converting lineal measurements to different types of units was demonstrated. The same type of conversions need to be made when performing area calculations. For example, carpeting is sold by the square yard. So when you talk about carpet, buying carpet, or selling carpet, or needing carpet, you basically talk about it by the yard, just like you talk about concrete by the yard, or gravel by the yard. It's the cubic yard. And that's the cubic yard. Concrete's the cubic yard. Yards of carpet are square yards, not cubic yards. But seeing as how carpet's about an inch, it's pretty much cubic as well. Same type of conversion. Okay. To make conversions between square inches, feet, and yards, you must first know how many square inches are in a square foot and how many square feet are in a square yard. Before we go to that next page, Ben, how many square inches are in a square foot?
Well, no. Square inches in a square foot,
Yep.
1.4.
Yes. 144, 12 times 12, 144. 144 square inches is a square foot. So you get square inches, you want to know how many square feet, divided by 144. And this should tell us that. And indeed it does. It
Oh, it was
says,
right there. Sorry.
well, that's why I didn't want to go to that next page. So we need to figure it out. You did. Good job. 12 by 12. So if you were to count every one of these squares, you would end up with a total of 144. A foot measures 12 inches, a square foot measures 12 by 12, and applied to the area formula, a square foot contains 144 square inches. A yard can also be expressed as 3 feet. A square yard measuring 3 by 3 applied to the square feet formula then contain 9 square feet. So a square yard equals 3 feet times 3 feet, which is 9 square feet. To make the conversions between square units, the following formulas are used. So square inches equals square feet times 44. So if you want to know the square inches in a square foot, take the square feet and go times 144. If you want to know the square feet, how many square inches in square feet, you take the square inches. I'm sorry. If you want to know how many inches, how many square feet are in X amount of square inches, you divide the square inches by 144. If you want to know the square feet, the square yard, you do times 9. And if you want to know how many square feet in a square yard, you do divided by 9. That's a little confusing when you say it, but it's not that confusing when we actually do it. So let's do some stuff here. Let's do a subfloor estimation. Building a house, the floors must be sheathed before the building exterior walls and partitions. To determine the amount of subflooring, the area of the floor needs to be calculated. And then the square footage divided by the area that's covered by 1 sheet of flooring, which is 32 squares. So 4 by 8, right? So how many sheets of 3/4 TNG sheathing are needed for the floor system below? Well, 32 times 46 is what? Anybody, whoever's fastest on the draw with their calculator.
1472.
1472? All right, so 46 times 32 is 1472, right? And that's what? That's square feet, correct? And the sheets that cover that are 32 squares each. They're 4 by 8, which is 32. So 32 into that number.
46.
46, right there. Look at that. 30 times 48 equals 472, equals divided by 32 equals 46 sheets. So we're already into our unit review. So let's, what's the area? Determine the area of the following polygons. A square with 9-inch sides. What's the area? Just shout it out. How about Brandon? What's the area? You just text it to me?
Maybe.
81?
Brandon, you there?
You just turned off the.
Yeah.
Oh, shit. Sorry. Brandon, you there?
Yeah.
What's the area of 9-inch square?
81?
Very good. Was that a question or is that?
No. It was the answer, yeah.
Yeah, good job. Good answer. Okay, how about a square with 8-foot 3-inch sides. Michael Silva, what's the area of a square with 8-foot 3-inch sides?
That is, here, wait, hold on.
Hmm.
12. Wait, what? Oh. Wait, I did something way wrong. I'm converting it to inches and then I got all screwed
Yeah,
up.
don't convert to inches, convert to feet. Do not convert to inches. It's way easier. So 3
Oh,
inches,
yeah, it'd
3
be,
inches, 3 inches is how is 3 inches expressed as a decimal equivalent of a foot?
it's a quarter.
Exactly. So that would be 8.25, correct?
It'd be 68 and 5/8 feet.
That's exactly correct. 68.0625 feet. You get that, Dylan?
Yeah.
And how to do it?
We were just talking about how to get the fraction in, or the decimal.
Into a fraction.
on these,
Or a
calculators.
fraction into decimal?
Yeah.
Okay, so a rectangle with a length of 12 inches and a width of 8 inches. Let's see, Joel Santos, can you answer that for me? What's the area?
Rectangle, so 12 times 8 is 96,
Exactly correct. 96 what?
96 inches.
96, that's not the answer.
Square.
Oh, is it 19 square inches?
It's 96 square inches, right? You got the 96 right. It's definitely 8 times 12, no problem. And you got the inches right. But 96 inches is not the answer to that problem. It's
Right.
96 square inches. Now, if it was, what's 8 inches times 12 inches? That's 96 inches. But what's the rectangle's area? That's 12 inches by 8 is 96 square inches. You got to get the denominators right? The denominators are 4 times 10. So let's go on to question 4. Okay, so how about, did I ask Joel Santos? Did I just ask you, Joel? I didn't, did I? Joel, are you there?
Yeah, you did. I
I
just
did.
answered.
Okay, that was you.
Okay, I've got an answer.
Hey, did I take roll yet? What was that?
I've got an answer if you want,
For which?
for number 4.
Okay, so we'll wait before you give it to us. Let me ask it. So a rectangle that's 7'10" and with a width of 6'4" is how many? What's its area? What is its area?
49.61 square feet.
Everybody concur with that?
I was.
Yeah.
Plurals.
And so how he did that is we got to turn 10 inches into a decimal, right? And the way we do that is we don't hit our phone, we hit our calculator. And we go 10 divided by 12 equals 0.8333, right? So it's 7.833 times 6.33. Would you say it was, look,
49.61.
I get 49.58, but that's definitely close enough.
Well, the construction master calculator is pretty nice because you can put in.
Yeah, you put it in inches, feet and inches, and it converts for you.
Yeah, so I didn't have to
Yeah,
do that.
that's cheating, and I want that, I don't ever want to see that again. Because we don't all have those.
I'm sorry, what trade are we in?
We don't have those.
They sell them at Home Depot.
Yeah.
Great.
They're over by the
Hey,
levels.
out there in Zoom land, anybody have a construction calculator on them? No?
I don't.
No?
No.
How much
Nobody's
are
got
they?
'em. You guys put those in recycle right now. Okay.
Most important tool in your toolbox. You do rise over run and everything.
Yeah, no, I want to see that thing.
Stair, there's a stair button, calculating stairs.
Yeah, but we're gonna,
Go to the app store, you can download it.
wonder about those dots. So I actually lost some money. I know everybody's really interested in that. So how about a triangle? Let's get John Tapia, who's right here in front of me. I know you guys at Zoom can't see that, but I swear he is. Let's get him to figure that. I need you to tell me what the area of a triangle that's 14 foot on the base and 5 foot high. What's the area?
35.
35 what?
Triangle, so it's not square feet, but
Yeah, it's
Yeah.
square feet. Yeah. Yeah, triangle has square feet. It doesn't have
it doesn't
triangle
make
feet.
sense.
Doesn't have triangle
Well,
feet. Yeah, so the area of a triangle is not in triangular feet. It's square feet,
Okay.
right? And the square foot is figured just like you did. You know, 5 times 14 is 70, half of that's 35. 35 square feet, because we're going for area, and area is expressed as square feet. Square feet, square inches, square yards. Okay, so a triangle with an 18'6" base and a 9'9" height. How about, let's see, Austin, can you give us that answer?
Sure. It's gonna be 18.5 times 9.75, which is 180.375, and then divide that by 2, so 90.1875
Exactly.
square feet.
Thank you for walking us through that too. So I'm sorry, I cut you off. What were you saying?
No, that's it. 90.1875 square feet.
Yeah, and then that 18.75, that's 3/16, right? Yeah, that's 3/16. 3/16 of an inch. You can convert that back. And you probably would at one point. Okay, so here's a
Yep.
real thorny one. The house shown below will be used to answer questions 7 through 10. So what's the area of wall A? Well, that's pretty easy, right? We're gonna go 9 times 34 is 270. 9 times 30 would be 270. 9 times 4 is 36. 36 and 270 should be 306.
Yeah.
Right? Everybody else get that? Okay, so what's the area of the entire gable? Well, somebody please punch in 36 by 14.5
1,044 square feet.
times 2.
That's after, yeah, you already timed.
Oh, you did that?
Yeah.
Okay, all right. So what is it again, 1,044 something? That sounds good. Everybody's just, if you have any questions, stop me, but see how we did that. You could do that a couple of ways too, by the way. You could do 36 and 14.5 times 2, or you could do 72 times 29. Be the same answer. Plug that in for me, will you? 72 times 29. Is it the same answer?
So it's double.
You double twice.
Oh, so I only want to do it once, huh? Yeah, so it would be 72 times 14.6. That would give us the answer. That makes sense. Okay, yeah, that's right. But really, be safe. Figure 1 and then do it times 2, or add that one to itself. That's the entire gable. It was that many square feet. I can't remember what he said, but it was the right answer. And the area of wall B. Okay, so who wants to do the area of wall B? I want to volunteer. Zach? Okay.
I love volunteering.
Way to volunteer, Zach. Way to volunteer. So Zach, take us through your thought processes and give us the numbers there. What's the area of wall B?
Okay, so you're gonna want to split it into 2 portions,
Yes.
the rectangle and the triangle.
Yep.
So let's do the rectangle first. That's 26 feet times 9, which is 234. Keep that off to the side for a second. Then we're gonna figure out the triangular portions area, which is 26 times 8.3 divided by 2. So let's multiply that or convert that 8.3 into feet, which is going to be 8.25 multiplied by 26, and then divide by 2. Add that to the rectangular portion, which was, I lost that, 9 times 26. You're going to get 341.25 square feet.
Excellent. So you see how that works? Just break out the rectangle, break out the triangle, and then after you do the square feet of both, add them together. I just had a thought that totally escaped. What the heck was it? All right. Don't ever get old, you guys. You start losing it, just take yourself out of the game. It's not worth it. Trying to remember stuff all the time. Like you walk into a room, and go, why am I here? Seriously, I mean, it's kind of funny, but it's kind of, it happens more often than I can tell you.
Did
Why
you
did I
take roll?
walk in? Why did I walk in here? I mean, like, why am I here? Did I take roll? It's interrogatable. Okay, what's the area of wall B? Wait, we just did that.
Yeah.
Thanks to Zach, we did wall B. Now, what's the area of the exterior walls for the entire house? We go back. Okay, the entire house, exterior walls for the entire house. So, we're not going to do this one, but basically you do wall A, which is 34 by 9. You get that, and then you do that times 2. That would give you both wall A and its opposite. And then you do what Zach just did on B, break into the rectangle below and the triangle above, and then do that times 2, then add both of those guys together. That's the area of the house. And that's going to give you a number. Well, you know what? Let's just do it just for grins, because I want to take it a step further. So we're going to make that, somebody write this down for me, please. You ready?
Yeah.
Write down for me, if you wouldn't mind. God, I hate that. I spiked the wrong way. Okay, here we go. Write down times 34 equals times 2 equals. Write down 612, please, and times 2 equals 468. And 214.5. Now, that 214.5 was the 8.25 times the 26. I didn't have it. I did not take it in half. Why? Because it represents both gables. Okay, so what'd you get with that whole thing? Give me those numbers, actually. You got the numbers?
612.
612 plus,
468.
damn it, I'm sorry, 612 plus 468 plus
214.
214.5 equals. Okay, so it comes out to 1294.5 what?
Square feet.
Okay, now what can I do with that? What would I want to do with it?
Paint.
I'm going to sheet the whole place with 4x8 sheets of 1/2 inch CDX. So divided by 32 equals 40.45 sheets. Can you buy 0.453 of a sheet of plywood? No. So how many sheets am I going to need? 41 sheets. You're always going to go up to the next sheet. So 41 sheets, and you may need more sheets than that. Before I order like that, I usually try to see how my sheets are going to work. That if I can figure some waste, if I can make them work out just exact, or if I know I'm going to waste some stock. So I may get a sheet or two more. But the price of plywood these days, I would be really careful. Okay. All right, we've been here an hour. Let's take a break, 10-minute break. Come back at 7:10 and we'll continue this. And this is the one that gets weird. Really weird.
The next example, or?
Yeah, and it's question 14. I had a lot of trouble with it, but I finally got it. Simple as it actually is. No. Oh. I should probably stop recording. What? somebody's gonna,
I was at a job and I almost got hit by a golf ball.
were you over by Alisal?
The Montecito one.
Oh, Montecito Country Club?
Yeah,
How close?
like 2 inches away.
Wow, so when you weren't on the country club property, you were in one of the adjacent.
No, I
properties?
was at a house.
Up on Scenic Drive, is that where it was?
Yeah, I think so.
Yeah, that's that, all along that second fairway. Of course, I don't know where it is now since they redid it, but that second fairway, there's all those houses on Scenic Drive. Yeah, because most golfers, errant shots are to the right. Most golfers, most people are right-handed, and most golfers come from the outside in rather than the inside out. And so they have a tendency to fade or slice the ball, which makes it go right. It makes it go to where you were working. And man, I have a couple that we replaced their windows, some that were friends and longtime customers. And this golfo found a way in their kitchen window that, I mean, it was the window that it had to get there was like a foot by a foot to actually, make it through all the obstructions and hit their kitchen windows like 30 million shot. But yeah, a golf ball could have killed you, man.
I know. No, me and my other coworker was like, should we like play dead? And then so we could get like a fast check.
Yeah,
then-
if you play dead, you're gonna have to really
No,
die.
no, not play dead, but like
Then you're gonna
like
have a
be
lot
injured.
of- Yeah.
Like be injured or something.
Yeah,
But then
here, hurry, take this hammer and smack me in the head with it. Yeah, golfers are responsible for their balls, for their testicle, I mean, for their golf balls and anything that happens, anything that hits, anything that happens, anything that they hit or destroy with their golf balls. Yeah, it's a drag getting hit by a golf ball, but it's a great game. I hope all of you get to know the joys and the frustrations of golf, because it's a super frustrating game, but it's one of those games that you have to have total focus and total concentration, but you can't hold on. You have to have loose hands. You can't have a bunch of thoughts in your mind. Actually, my swing thought is no mind. I say those two words in my mind until my mind feels completely quiet, and then
There's a zone over by Dos Pueblos on Cathedral Oaks
yeah,
where you'll either get hit by a golf ball, baseball, or tennis ball.
yeah,
There's just that one zone.
yeah. It's a
You
magnet.
drive by, you'll say, you'll just see a bunch of golf balls or baseballs, and tennis balls.
Yeah, I know that. Glen Annie, golf balls from Glen Annie. Share me. So this is the one that gave me some fits. So what's the area of the bedroom? It's 12 foot by 11.75. So I just want you to, this is the big point here. The big point is that when you're doing square calculations for area, square feet, square yards, and typically you do stuff in square feet. You might do stuff in square inches, then change it to square feet. And when you get your square feet, you might change it to square yards. But you do this a lot. And you need to be able to put your inches into a decimal equivalent. It's the easiest way to do it. If you don't have a construction calculator, if you can't plug in, 6 and 4 5/8 inches, right? Because you can probably do that in that thing. You need to be able to convert inches into a decimal equivalent. And just remember, whatever the inches is, just put it over 12 and divide the 12 into it, and you're going to have a decimal equivalent. It's just that simple. But get to know, just like your times tables, that 3, 4, 6, 8, 9, all those. So 1 and 2 inches, no. 5 inches, no. 7 inches, no. 11 inches, no. 10 inches, no. But all the rest, 3, 4, 6, 8, and 9. Piece of cake, right? 3 inches is a quarter, 4 inches is a third, 6 inches is a half, 9 inches is 3/4, and 8 inches is 2/3. Okay, and then after a while, you'll get the numbers that pop into my head are when I say 2/3, 0.667 just pops right into my mind. When I say 1/3, 0.3334 or 0.333 pops into my mind. I know that 2/3 is 0.666, 1/3 is 0.33. That's really all you need to know. And then again, it's, you know, easy enough going, oh, what the heck is 5 inches in decimal equivalent? Well, it's just as simple as 5 divided by 12. It's 0.416. And you really, in these decimals, you don't need to carry them any more than 3 places. That's as far as you'll ever need to carry them. So just round. So, and just use rounding, round up or down. So 0.41666 would be 0.417. 0.33333 would be 0.33333. 0.66666 would be 0.667. 2/3. So anyway, the bedroom is 12 foot by 11.75, right? If you have any questions, stop me. The utility room would be 8.5 times 7.5. The deck would be 14.5 times 12.5. So that answers all of those. I'm more concerned with how you got there, because you're all going to have calculators on this, on the rest of it. And as your life goes on, you're going to have your phones and your calculators. So as long as you know how to press the numbers and what sequence, then you should be fine. You should get those the good answers all the time. So the area of the utility room, the area of the deck, we did all that. Okay, so this is a tricky question. Now, I want you all to work on this and figure it. And I want the first one that comes, as soon as you come up with the answer, yell it out, and then tell me who you are, and we'll see who gets it right. So what's the total area of interior walls if the walls are 9 foot tall? Now I want to qualify this, all right? The interior walls would be the inside, not a wall that's an exterior wall of the house. We're talking about the interior of the walls of the house. Okay, so the question is, what's the total area in square feet of interior walls if they are 9 foot tall? Okay, get to work. Come on, you guys. Whoever gets it first gets a prize.
Can you show the map?
Finish
Oh, my book.
Ben's coffee. No, just kidding. We can have that stale, whatever that is.
Rodney, can we see the floor plan again?
Yeah,
Yeah.
I did this. I had to work this out. I did it. I did it to my own satisfaction.
Can we see the thing?
Somebody talking?
Can you hear somebody?
Yeah.
Okay.
It's just somebody in my head.
Rodney,
Put the thing on,
Yes,
the house.
he's
whatever.
probably already got it done.
hello, can you hear us?
Yeah, I can hear you guys.
No, but they can't. That's the problem.
Got an answer. I don't know if I did it.
What's your answer?
198.
So
Or just the
Lou
wall.
got 198.
That's just the interior.
Yeah, interior walls. That's it. Interior walls. You got 198, which by the way is wrong.
Yeah,
198 what?
square feet.
Okay, that's wrong.
Yeah, totally wrong.
Who else? Come on. Come on, man. Come on. So we got one answer is 198 squares, which I've already included everybody in, that that's not the right answer.
I got one.
What do you got?
3,111.75.
3,111.75 square feet. Wrong. Who else? Anybody's at home? Come on. You guys have all got calculators. You've got the, oh, I'm sorry. You know what? I'm so sorry because some of you might not have the book. You got. All right, sorry about that.
Thank you.
Yes, I'm so sorry. That's gonna help, huh?
But I think what we did wrong is
That's gonna help a lot.
it's an even number.
It's actually not an even number, by the way.
No, 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 yeah.
Come on, man, we got 2 answers out of 16 people.
Everybody else is just afraid of being wrong.
Come on.
1,192 and a half.
Okay, let me write that down. I'm sorry, what was that again?
1,192 and a half
Okay, that's
square
wrong.
feet.
You just did that.
That's wrong.
Well, it's just, all it is.
Anybody else?
It's.
Anybody else? Anybody?
Wait, I'm still doing it.
Okay. John, what do you got? Ben, what do you got?
Almost. 488 on a quarter.
488.25 square feet, right? Okay, wrong?
67.5.
That's way wrong.
Wrong? What else?
Really, Dax is wrong?
You can't count, you're not counting. Come on, anybody else? Come on. That's still only 5 answers. John, what'd you come up with? What did anybody come up with at home?
No, it's all of these.
I got 715.5 square
Who
feet.
said that? Is
Austin.
that Austin?
Yeah.
Because this is the exterior one, but the right inside of it.
That is absolutely correct.
Can you do it on the board?
Yeah, I'm gonna do it. I'll do it on the board. Fine. Actually, I'll do it. Everybody look at this, right? Just look at the screen. We'll do it right here very easily. Okay? And you'll see it. You'll see it. Basically, there's 79.5 running feet of wall. So you need to find out how many running feet, that is lineal feet, of wall is there. And then you just take that times 9, and that's your answer. At 79.5 lineal feet of wall, at 9 foot tall, it gives you 715.5 square feet. And here's how I get 79 lineal feet of the interior walls. Let's take that utility room for starters, right? It's 8.6 by, well, it's 8.5 twice is 17. So 17 plus 7.5 twice is 15. 15 plus 12 twice is 24 plus 11.75 twice is 22 plus 1.5 is 23.5 equals. God damn it. What do you mean invalid format? All right. Okay, somebody add up 17, 15, 24, and 23.5.
79 and a half.
Yeah, that adds up to 79.5. So those are your walls. I just added the walls, the interior walls. All 4 sides of the utility room and the bedroom are interior walls. Right? So it's kind of it was complex to me. I didn't get the right answer either. I started out with Dylan's answer, 64 and something.
67.
I kept trying, or 67. I was going, no, but that's contiguous wall. But then that's like, then I realized how simple it really was, and it is. And but I have an advantage over you guys, and I'm giving you the same advantage. That is, when I couldn't get the answer right, I went to my online instructor's resources, pulled up the answer, and then worked backwards from there. Divided 9 into it, came up with 70, whatever it was, 79.5. So I knew there was 79 lineal feet. And then I said, well, wow, that looks suspiciously like what all those things would add up to. And then it was. So I doubled every one of those numbers and they added up to that number. And then I saw, oh, pshaw, of course, that's how it works.
Well, thank you for sharing your advantage. We don't have that.
Yeah, sorry. Well, you do on the odds, right?
On the
Isn't it?
odds, yeah.
On the odds.
That's
Was that an odd?
Dylan was going for it for the back.
That was an
Man,
even.
it's an even number.
You gotta try it.
Oh, that was the number, that was the one before. Yeah, that's when you got that 63.75. You just went for the answer before?
What is it in there?
You're busted.
No,
No,
I found-
actually,
I found
no,
this.
that's not it. 63.75 is the answer before. But, okay, so what do we got here? Convert the following area dimensions. Round your answer to 2 decimal places. So 365 square inches. I'll do this one. I want to know how many square feet is 365 square inches. So I'm going to very simply take 365 divided by 144 equals. It's 2.53 feet, because my calculator says 2.5347 da, 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 da. He wants it two places. 2 places would be the hundreds place, which is the 3 place. To the right of the 3 is a 4, which is less than 5, so it drops off. So it's 2.53 should be that answer. Sure it is. Is it?
Yeah.
Good. All right. Now, somebody else do this. Somebody else do square yards, 16 square yards into how many square feet? How many square feet are in a yard, in a square? How many square feet are in a square yard?
9
Exactly. So how would you find out how many square feet are in 16 square yards?
times 9.
You'd multiply it times 9. 9 times 10 is 90. 9 times 6 is 54. I'd say it's 144 square feet, if you ask me.
You hit it twice.
That's the answer, 144 square feet. And it's really, because we're using calculators, I can't stress this enough. As long as you've got the process right, you've got, what you're doing right, then you're going to get the right answer every time because you've got a calculator. You're not going to be making mistakes in addition or subtraction or multiplication or division. If you plug in the right information, it's kind of like garbage in, garbage out, right? Or, okay, so 5.6 square feet equals how many square inches?
806.4.
And how did you get there?
Multiply 5.6 times 144.
Exactly. So, because there's 144 square inches in every square foot. So you take 5.6 square feet times 144, that's going to give you square inches every time. It's going to be right every time. So what about 487 square feet? How many square yards is that? Just tell me, how do you get there? How do you find that answer? Somebody, anybody, somebody from home? Eric Mendez, did you make it?
Divided by 9.
Exactly. John just asked that as a question, but it's the answer. You divide it by 9 because there's 9 square feet in a square yard. So 487 square feet divided by 9 is going to give you the answer. And if I think about it, I'm not going to.
So it's 0.1 repeating square yards.
Say again, please.
So the answer is 0.1 repeating square yards.
Oh, hell no.
No, that's not.
It's definitely not right.
54.111.
That sounds a lot more like it. Let me just check here. 487 divided by 9 equals 54.11111.11, because we're going to just 2 decimal points. So, okay, this is a good one. So 15,552 square feet. Jose Silva, I want you to try to answer this for us, please. 15,552 square inches. How many square yards is that? And tell us how you're figuring it, please.
Okay, so wouldn't that be 15,552 square inches times 9?
No, it wouldn't be. Here's how it's done. Or so, does somebody else want to tell me how it's done?
Convert it to square feet and then convert it to square.
Yeah, so you can go square inches right to square yards, but it's a lot easier to convert those square inches into square feet and then convert your square feet into square yards. And how you do that would be you take the 15,552, right? Square inches divided by 144, because that's how many square inches are in a square foot, equals 108 square feet. 100 square feet, if you want to know the square yards, you're going to divide that by 9. I happen to know it's 12. So 15,552 square inches is 12 square yards. And as long as you know that what you plug in to your calculator is 15,552 divided by, you know, that symbol with the line and the 2 dots above and below, 144, you're going to get a number. That's going to be your square feet. But you need the answer in square yards, and now you need to divide 9 into that. And if you ever are wondering about some of this stuff, you know, in the back, there are all kinds of tables. There's summary of formulas. There's, let's see, how can I get there? Well, I can't get there, but I think most everybody has the books, but there's board feet, Pythagorean, there's rectangular solid. There's just a ton of summary of formulas. There's customary conversion charts, dress lumber sizes, inches converted to decimals, common decimal equivalents. There is, in these 2 or 3 pages in the back, there's a ton of really good information. And as a matter of fact, if you didn't want to carry around this big ass book with you, and I don't know what an ass book is, but if you don't want to carry around this big book with you, just take a picture of those last couple of pages and go pull it up on your phone and go, oh yeah, here's that formula. Because those are very useful formulas. Okay, next. How many 4x8 TNG sheets of subfloor are needed to sheath a 30-foot by 68-foot floor system? Now let's see what victim. Matthias, can you do that problem for us and tell us how you're doing it, please?
Yeah. Hold on.
Okay.
Um, 4 times 8. Fuck.
That's not the answer. Well, sometimes it is, but
Sorry, I said it.
that's okay. Okay, I'm going to show you, I'm going to tell you how to do it.
Yeah, could I have some help, please?
Yes, I'm giving you some help right now. So, and again, it's not so much the numbers in this case, even though it's the number you're trying to come up with, the correct number, right? The answer is the number of sheets of tongue and groove that are 4x8, which are 32 square feet. So you need to know that 4 times 8 is 32. You need to know that a sheet of plywood or TNG in this case is typically all your 4x8s are going to be 32 square feet. So
Yeah, I got that part.
Okay, I figured you did. I wanted to give you a good basis. Now to figure out what the square foot is in the 30-foot by 68-foot floor system is you just multiply 30 times 68, divide by 32. It's really, it's two things, 2 moves on your calculator.
So
30,
63.75.
Exactly, times 68, exactly, equals, divided by 32, equals 63.75. Can you buy 3/4 of a sheet of plywood?
No.
No.
Go to Home Depot, kind of ask.
So it'll be 64 then?
So you buy 64, yeah. But the answer to the question, if this were a test question, by the way, even though, and I'll try to clarify this when I do the test for you guys, even though there are no 3/4 sheets of plywood, the answer is going to be 63.75. That's the answer we're looking for. That's the answer. I bet you. Is it odds or evens? It's odds, right? Did you look?
That's an even number. 22.
No, it is. Yeah.
So if we put 64 sheets, that would be wrong technically, or you would.
Technically, you know, that'd be one of those things where I'm going to look at it and probably give it to you, right?
Yeah, because it's asking for 4x8 sheets, so wouldn't the correct answer is 64?
It's true. Well,
Because
I suspect, I'll bet you if I go into to my resources, I'll bet you the answer they give is the 0.75. Bet you it
I'm
is.
really curious.
So at this point, I'll be willing to buy the actual answer 0.75 or sheets. But in the real world, the problem is this is not the real world.
Right, well, and they're
They're-
asking for sheets.
Mm.
for when-
I know they're asking for sheets, but okay, I'm gonna have to
Yes.
go look right now.
Well, they're getting complicated with it.
Let's just look just for the hell of it, because now you
How
got,
how many sheets?
what
are
number is
going
it?
on
22? 22, right?
Yeah, for unit 17.
22, where am I?
Anyway.
I think
Whoa.
the book's taking it
real 64 or 63.
13.33.
Well, the book's taking it direct. It's gonna give you the exact answer of how much material is going down. But in reality, you're gonna get extra material.
It didn't say how much material is going to be. It said how many sheets.
Yeah, it does. It says so many sheets, it does, but all that, what unit is this, 17?
But again, it's taking it literally.
17, question 22.
Who cares what the academics think, though?
63.75 sheets, period.
See, it's taking it literally. It's taking, because you're gonna cut a sheet in half. That makes -2 sheets.
So this book, when you get it, you just got the definitive answer.
Right,
Your answer should be 0.75,
okay.
unless I give you some instructions saying, by the way, if it comes up to it's the real world, go to the next sheet, right? Just be literal. You won't get it wrong if you're literal at this point. And even though if you notice on the midterm, you know, a lot of you did like in cents, you went to points, you know, you went beyond cents, you went half cents and stuff like that. And I made comments about there are no half cents, but I still gave it to you. I didn't mark any of those wrong. You did the math right. But in things like that, and you know, it's really a good point. You know, it's a stupid answer because you can't buy 3/4 of a sheet, just like you can't spend 11.5 cents.
I have a real world question. Let's say that this area of floor system,
Which one are we doing? Let me
say 22.
let me pull it up. Let's see.
It's telling you how the sheets go down. They're saying you're cutting a sheet in.
And we just have to give it one theoretical.
It's 8, we're at 18, right?
22. Oh, sorry. Unit
Unit 18, isn't it?
17.
17.
It's, we're on 17 still?
Yes.
Oh, yeah, that's what. Okay, 22. So I'm sorry. Is it 22 you're asking about?
Right, same question, but
Okay.
I have a mock. Let's say that you took a while to get that area because that construction is conformed by weird shapes because that's how the architect wanted it. And it has like, let's say a triangular bathroom and then a funny window. So in the real world, if you know you're gonna have many odd cuts and that you'll have to figure out several angles, that in my thinking is I'm gonna have a lot of waste.
Yes. Yeah, so
How
so
will you
the way you deal with that is when you know you're gonna have a lot of cuts and you have some strange shapes, is you just give yourself a factor. 10%, 1 sheet, 2 sheet, you know, just throw something in there or really crunch it. See how, like I will take a sheet of paper and just sketch, you know, and apply. Or if I'm really thinking, I'll do it to scale. And usually things repeat, right? So you go, well, that odd shape, what if I did it like this? And how many of those pieces could I get out of a sheet? You know, you could do that too,
Okay.
or just get a couple extra sheets, let your guys figure it out on the side, or you figure it out on the side, and then hopefully they'll take a sheet back or 2 sheets back.
Okay.
But
Alright.
it's a good question, and it comes up all the time. And most people just go, oh, add a sheet, oh, add 2 sheets for waste, you know, and there are multipliers like that for like decks, for instance. You know, typically you can use it. People like to use a 10% waste. 10% waste, 10% overages. To get 10% over, when you're doing a diagonal, it goes to 15 to 20. On the diagonal, you have a lot more waste on a diagonal. But there are factors and multipliers. that-
Diagonal, you mean that the boards go
Yeah,
diagonally?
if you're running your deck on 45s.
Uh-huh. Okay.
I like to figure, I like to figure stuff as tight as I can possibly figure. I like to figure out what I'm using, if I can use the outfalls, I get big enough so I can use the outfalls. If I need, you know, if it's 7.4s, should I get 16s and have a little bit out, you know? It's just, there's a lot of ways to do it. You can do the big scatter shot, just come up with square footages and add a factor. call it an FU factor. But yeah, you always want to add something for waste, unless you've got just translates to 4 foot and it's 8 foot tall, it's equal sheets. You still might want to figure waste anyway, because somebody's going to mess something up. It's been my experience after doing this for a lot of years that everybody messes something up every day. Everybody screws something up every day, including myself. And everybody that worked for me messed up at least one thing at least once. And I messed up something at least once. And for myself, I learned the hard way, because just when I would be on your case for messing something up and getting, in a big tirade and on my high horse, I would make some hugely dumb mistake. Always. So I try to give people a break, because, it's hard. You miss stuff. And the thing about estimating that I found over the years is that you will never get it. You'll never hit it on the button. You can only hope that you'll make it in some areas and lose it in some areas. That's what's going to happen. And then it'll balance out. And that you got that margin close enough between the losing it and making it so that you can keep going. I mean, I had jobs. The best job I ever did was I think it was, my end was like 1.3 million. And I netted $365,000 on a $1.2 million job that took 2 months. It was a fast track, 9 buildings in Isla Vista, complete remodel. We remodeled 176 bathrooms.
Wow.
Yeah, 176 bathrooms, and it was like a 2-month time frame. It was insane, but I hit my numbers, man. I just hit it on everything. And I kept plugging in the numbers, going, that's impossible. That's impossible. I couldn't have made that much. But I actually did. And so, you know what I did right then and there? I got an apartment in Rio de Janeiro for 6 weeks. I bought both my daughters new cars. I bought myself, I can't remember, that was a Harley or something. And then I went to Rio de Janeiro. And then I was in Rio de Janeiro for a couple of weeks. And I got back and forth on my laptop talking to my office, and I got an email that said, hey, Ben and Julie, our accountant, said, you better hang on to some of that money.
Oh, no.
Your corporate tax bill is $168,000. So, what? I didn't hear that, right? And then that story continued. So I fired those accountants 2 years later when I was in a La Cumbre Country Club golf tournament, and was introduced to a hot shot CPA, Barry Gellert. This guy, very hot shot CPA, really high end, super smart. I told him about that. He says, you shouldn't have paid me taxes. And so I met with him, showed me what was going on. I fired my accountants. He got me back in the next 2 years, $115,000. Of that 168, I got back $115,000. Now he told me, set aside at least 30% of that, because that's going to be straight income. That money you get back, and you're going to have to pay taxes on that. So, but still better than opening the option.
Wow.
And that's just one example of when you start doing this for a living. If you get beyond working for someone for a living and start being an employer and having workers' comp and liability and STI and vacation time and sick leave and health insurance and all the stuff that you're responsible for, and estimating and markup and overhead, all that stuff, you will go on to another level. And it just keeps, you never get there. You know what I mean? You never get there. There will be another level. It's fast. It's really satisfying. And you can make some money, and you can really lose some money too. So just, if you're good at it, and you're tooled and you're working for somebody good, consider working by the hour for a while and making some bank, man, because I made good money by the hour. And there were years where I lost tons of money as a contractor, where my guys all made money, my subs all made money, and I lost money. What happens? But there were years where I made $375,000 on one job. So,
In 2 months.
okay, so here we go, in 2 months. How many sheets, roof sheathing are needed to sheath the 28-foot long gable and a 13-foot, 13 verse slope? We're not gonna do that one. What's the area of this wall? Well, it's the rectangle below and the area of the triangle above, right? Anybody have any questions on that? The only fly in this ointment is what's the base of the triangle?
48 minus 28.
Yeah, it's 20 feet, right? It's 20 feet. 20 times 9 1/4 is 185. Divide that in half, is 92 and a half.
What would that 28 part be on like an actual house? Like literally, would it be like a flat roof? Or
No.
would you have something like that on a house? Or-
Well, yeah, you might, because this part here, the 28-foot part,
Yeah.
could be a gable going the opposite way. So an intersecting gable,
Oh,
right? So you're doing the wall surface, and that's a gable end wall. That's all wall flat, and then falling away this way would be another gable, and that's not part of the wall surface. Because that you could very well see exactly that.
yeah.
Matter of
It
fact,
looks like a
my
weird
house,
structure.
if you took the roof off my house, you'd see that. All right, how many pieces of sheathing are needed to cover the wall? How many square? I don't care about that right now. Okay, the ceilings of a 24 by 26-foot addition and a 14-foot by 12-foot 8 mudroom need to be insulated with insulation that covers 88 square feet per bag. How many bags are needed to insulate both ceilings? Round your answer up to the nearest full bag. So let's just do it. All right, let's do it. So I'm going to ask somebody to write some stuff down for me. So the first thing we're going to do is the addition is 24 by 26. So 24 times 26 equals, that's 624 square feet. And then the mudroom is 14 times 12 point what? 66. It's because 8 inches is 2/3. 2/3 is 0.66 equals 177.24 rounded down. 177. Okay, you got that? You got that first number I told you, and then we're going to add that to it. All right, so add those two numbers together, please. 177 and the other one.
801.
801. Okay, and then we can just divide 88 into it. So clear 801 divided by 88 equals 9.10 bags. Round your answer. So this tells you, right, to round your answer up to the nearest full bag. Up.
10 bags.
So even though it's 9.1, it doesn't say round to the nearest. It says round up. That's a really important distinction, because when you see round, when we say round to the nearest, that means 4 and below, 5 and above, up. But when it says round up to the nearest full bag, it doesn't say round down. So even if that's 9.00003, get 10, right?
Yeah.
And typically, and I will make distinctions like that all the time, because those are real world problems. Because you're never going to get whatever that was, 9.111 of a bag. Then why would you get 9 bags and be short? You're always going to go with it. Just like you're always going to bump it up a sheet. Because you can't buy a 3/4
See, that's
sheet.
the wording we need to put on the sheet.
So what's the area of the hip roof shown? Well, that's kind of cool. I like that. All right, so let's do that one. Someone write down the answers I'm going to give you. So the first thing we're going to do the 2 gable triangles. And the way we're going to do those is we're going to do 32 times, well, it's 32 times 16. Do you see how I got the 16, you guys? You see how the length of the roof is 64. And if I take away the 32 feet on the ridge, that leaves 32. And I can see right now it's equal both sides. So it makes me know that's 16 is the height of that triangle, and the same thing on the other one. So the triangles are 32 by 16. And so instead of going 32 times 16 divided in half, there's two of them, it's just 32 times 16, right? So the first number is 32 times 16 equals, oops.
Couldn't you also just do it like a rectangle? Or not, like a big rectangle? Instead of breaking it down into.
Like 32 by 64.
Well, let's see how it works. Let's see how it works. Okay, let's see if it works. Let's see if the numbers work. Because it shouldn't work because it's not a flat surface, right? It shouldn't work, but I think in this case, because we're seeing it as a flat surface, and I think the slope,
Yeah, it
The
doesn't work.
slope's gonna make a difference.
the slope's gonna make a big difference because it's not 16,
Mhm.
it's 18.6. So it's 32 times 18.5. You see that?
Mhm.
So yes, yeah, if this was a dead flat roof, you wouldn't have those lines in there. It'd just be, there'd be no lines in the middle and it'd be 32 times 64. But because it's a hipped roof, you've got triangles. So that this is gonna be, you're gonna have to bust off a bunch of triangles actually. So you're gonna have, okay, so let's do this. Well, first we'll do the easy ones, the two triangles, which are 32 times 18.5. What is that?
Or do you mean 32 by 16?
No, I do not mean by 16. No. I mean, because 18.6 is the slope, so that's the base of those two triangles, is that 18.6. 18, I'm sorry, 18.5. So, so 18.5 times 30, oops.
590.
92 square feet.
592.
Damn it, 32, I want to double check it, times 18. equals- Yeah, 592, right? So somebody write that down, 592 square feet, you got that?
Got it.
Okay,
I know you want two of those, or we're just trying to find out one truck.
no, that's both triangles,
Okay.
because it's half of that is the area of a triangle. So 32 times 18.6, that, and gives you a number, half of that is one of those triangles.
Okay.
So I just didn't divide it by half because we got two triangles.
Right.
Right? So that, whatever that was, you somebody write that down, 592?
Yeah, I got it.
Okay, so now we've also got four more triangles and two rectangles. So let's do the two rectangles. The two rectangles are 32 by 18.6. So those are rectangles. So 32 times 18.5 equals times 2 equals, oops, damn it, 592 times 2 equals, so 1184.
Yeah.
Okay, we got that, and added to the other one, which is what, that was 592.
Yeah.
Okay, and now we've got four triangles that we got to figure out. You see those triangles there?
Yeah.
We got, so we know this guy. Do we know that guy? We don't care about that guy. All we care about is this. So we have we need that. We need the height.
Would it be
So we do need that.
16 times 18.5?
We do need that. You know what I mean? This is confusing as hell. Would it be what?
Well, you
Isn't
find
it 16 feet times the slope? That's your base times height?
No,
No.
no.
Wouldn't you
it
be able to
wouldn't.
find
See,
half
this
of
is-
one of the big triangles?
This is the base, right? Right there. That's the base of this triangle. This triangle. So this creates a triangle. This creates a triangle. That creates a triangle, and that creates a triangle, right? We've already broke out the 32 by 18.6 rectangle, that rectangle, that triangle, that triangle. Now we need those two triangles. So we need that, and is it gonna be 18.6? I don't think so, because that's on the hip.
It's
So-
gonna be, you can use the other two sides. You can use the 18.5 times 16.
Yeah, that's what I was saying.
Oh, okay. Is that right?
Which is 296.
18.5 times. And
Where
where
is
is
the
this?
side?
Oh, good times.
They cut that.
It's 16. Yeah. Okay. I got it. I like it. I like it. So 18.5 times 16. do that, and then do that times 2. Because 2 of them, right? One of them, anyway, 2 triangles
Would it be times 2 or times 4?
be times 2. Because remember, we're doing that thing on a triangle that you would have to have.
Right.
But since it's 2 triangles, we're not having it. So it's 4 triangles, so we're doing it times 2.
I got a question. What if you try to solve it like a trapezoid?
That's a good question. Hold that question. I'll show you.
So all of that added up is 4736.
4736, I'll add it up.
Yeah.
All right, let's see if that's right.
I got 592. 18.5 times 16
Oh, wait,
times
wait,
2.
wait. Yeah, hang on. Well, 592.
Is anybody else working? Anybody at home working these answers?
Yeah, I believe I got half of what Lewis says.
I got
Tell me,
2,880.
2,880, that's what we like?
Yeah, half of what.
I got something different.
Well, I'll tell you what, I didn't add those up. I mean,
2368. No?
Yeah, I have that.
How is that half of what I?
wait, you had two.
I must have misheard you, Lewis.
You
There's
had,
a bit of
you
a
had
delay.
2880, Zach. Did you just tell me 2880?
That's Austin.
Oh, I'm sorry, Austin. Did you tell me 2880?
Yeah.
What did you say, Zach or Lewis?
2368. 10 days. I'm going.
Okay, so since I called out those numbers, but didn't add them up. So I have no idea, but let's just find the answer. What do you say?
I think Dylan's right.
It's number 30, right? Number 30. Number 30.
I got 2288.
2288?
Uh-huh.
Well, we got 3 separate numbers so far.
Did you write down 10 bags?
Yeah, make sure you get 10 bags.
Number 30, 2368. Who said that?
Nice.
Who got that?
High five.
Lewis and I think.
Way to go, way to go. Zach and Lou.
From Riverside, high five.
But I gave you guys the answers, right?
Yeah.
I was doing it separately. You were confusing me.
Okay. That's good. It's good you did it. We're doing it separately. What are we on here?
Did you take a
Oh,
roll?
okay.
I think
17, unit 17.
I think that's a good thing.
Volume, we're in volume now, right? No, we're in area. Yeah, we're in area.
That was the last question.
That's the end of.
Okay, good. So now let's hit volume. I thought we could get to board feet tonight, but well, maybe not. What time is it? It's almost 8. So we had,
Potato 2.
do we have 2 breaks already?
1 break.
Did I take? Take a break. Let's take a break. Take a break. Take a 10-minute break. We'll come back. We'll get through volume measurement. We'll go home. We won't do board feet. I'll save that one. Okay. Just stretch your legs. Take a 9-minute break. 8:10. Okay. I'll pause this recording.
It smells like sugar.
Okay. Welcome back. Welcome back. Now we're going to talk about, now we're at unit 18. So we're 11 weeks in, right? We have wow. We have 21 units. We're about to do 18. That's going to leave us 3 units to do. It's cool. Okay, so our objective for this chapter is to calculate the volume of a cube, calculate the volume of a rectangular solid, calculate the volume of irregular shaped objects, and convert cubic units in measure. In the construction field, calculating volume is important for ordering materials. Volume is the amount of space inside a 3-dimensional object consisting of length, width, and height, or in some cases thickness. The volume of an object is always measured in cubic units, not square units, cubic units. such as cubic inches, cubic feet, or cubic yards. In construction, concrete is one example of a material that's always calculated in cubic yards. The volume of a cube. A cube is a three-dimensional square that has a height equal to its length and width. To determine the volume of a cube, multiply the three sides together and express the answer in cubic units. For instance, the volume of a 5-inch cube is 5 to the third power. 5 cubed, which is 5 times 5 times 5. 5 times 5 is 25. 5 times 25 is 125. 125 cubic inches. When calculating a cube containing denominant numbers, their units combine to create a cubic unit. Volume is then expressed in cubic units using a variety of notations such as cubic inches, CU space IN, or IN to the third power. I never do that, but if I did see that, I would know instantly what it means because it translates inches to the third power. Inches cubed, volume of a rectangular solid. A rectangular solid is a three-dimensional object with 6 sides in which all sides are rectangles. So determine the volume of a rectangular solid, multiply the length times the width times the height. Express the answer in cubic units. So this is inches. It's all inches. They all have to be the same, by the way, just like in area. Cubic, same thing. If you're to find cubic inches, you need to work in cubic inches. And the same thing in feet. You can't use feet in inches. So if it's feet you want and you have some inches, convert the inches to decimal parts of a foot, or convert the feet to inches. Easier to do. Convert your inches to decimal parts of the foot. So the volume of a 6-inch by 18-inch by 48-inch rectangle is 5,184 cubic inches, which is the length times the width times the height. 48 times 18 times 6, 5,184 cubic inches. Bam, just like that. When performing calculations, when performing volume calculations, all measurements must be expressed in the same unit. I just said that. Volume of irregular shaped objects. To determine the volume of an irregular shaped object, the shapes, just like area, must first be broken down into individual cubes or rectangular solids that can be calculated individually. Once the volumes of all the individual shapes have been calculated, they are then added together to determine the total volume of the irregular shaped object. You can do the same thing with triangles. Figure out the area, and if it's a three-dimensional triangle, then the depth or height of it. That'll give you the cubic. Once you get the square, you do it times the, because now this may address that, but to get a triangle's cubic dimension from a three-dimensional triangle, you would do the area of a triangle, which is those 3 ways of getting it, right? Base times height. Divide that in half. And then you wouldn't do any other dividing. Then you would multiply that times the thickness. So it was 3 inches thick, you'd multiply it times 0.25 if you were going for feet. To calculate the volume of the sidewalk, start by breaking the L into 2 rectangular solids. So it's pretty simple, right? 3 foot, you have 1 3 foot by 16, which is 48, 1 3 foot by 9, which is 27, 27, 48 should be 75. Right? Okay, it doesn't do it that way. So here's how this does it. Calculate the volume of the, oh, I see. Because I was calculating the area. The volume is continuing on with the third dimension. So first we get the area, 16 times 3 times 4 inches. So you do 6 times 16 times 3 times 0.333. That's 4 inches represented as foot, as a decimal foot. The answer is 15.984 cubic feet. Or you could do 16 times 3, 48, and do 48 times a third, which is 16. 15.984 cubic feet is so close to 16 cubic feet that you really should call it 16 cubic feet. And again, in my head, I would do that. I would do the area times the thickness. So 3 times 16 is an easy one for me. It's 48. And 4 inches is a third of a foot. So a third of 48 is 16. 3 16s make 48. So calculate the volume of the 9x3, same thing, 9 times 3 times 4 inches, I get 8.911, I'd call that 9 cubic feet too, because I'd go 9 times 3 is 27. 4 inches is a third of 27 is 9. 3 times 9 is 27. I'd add the 9 and the 16, which would give me 25, not 24.975 feet, right? Never would you need to go 0.975. And it really is easier to do it in your head when they're this simple. If you can do numbers like that here, if you can multiply 3 times 16 in your head. If you can't, practice. You're young enough, you can get that. You can. I only have it in my head because I've learned it early and I've practiced it my whole life. I've been doing this a long, long time, decades, like half a century. That's a long time, even for me. Okay, so converting volume measurements. Area measurement, the practice of converting area measurement from one square unit to another was demonstrated. In volume measurement, the ability to convert between cubic inches, cubic feet, and cubic yards is also a necessary skill. In the previous example, the volume of the sidewalk was calculated to be 24.975 cubic feet. Since concrete is ordered and sold by the cubic yard, the answer to 24.975 cubic feet would need to be converted to cubic yards. To make the conversion between cubic inches, feet, and yards, you must first know how many cubic inches are in a cubic foot and how many cubic feet in a cubic yard. Well, guess what? There's 1,728 cubic inches in a cubic foot. You're never going to need to know this. Almost never. I'm trying to think of it, if I've ever needed to know that there was 1,728 cubic inches in a cubic foot. I have never needed. But you do need to know that there's 27 cubic feet in a cubic yard. And I have known that a long time. So, but really, if I needed to know it, it's just 12 times 12 times 12. It's not that tough. And your calculator will do that for you. So since there's 3 feet in a yard, a cubic yard measuring 3 by 3 by 3 contains 27 cubic feet. Cubic yard equals 27 cubic feet. So there's those guys. I can't even repeat them. See them there? Mm-hmm. All right. So wait, these are sometimes longer. So calculate the volume of the slab below and convert to yards to determine how much concrete needs to be ordered. So 10 foot by 9.6. So 10 times 9.5 should be 95. It's a 4-inch slab. That's a third. So this is good. This is going to be 24, right? It's going to be, no, it's going to be, what did I say? 95, a third of 95. Well, a third of 96 is a 32. So it's going to be, I'm going to call it 32. And 31.635 is 31 2/3 cubic feet. Go ahead and use that. That's fine. Or 32. And then you got to divide that by 27, which is how many cubic feet are in a cubic yard. And you come up with the answer, which is 1.17. And if you did it, and if you rounded it in your head and you got 32 and did 32 divided by 27, you'd get 1.185, which you'd round to 1.19, which is not that all fire different. And it's always almost 100% of the time. I'm trying to think of times when there isn't. Better to go up, to have more. It's better to have more material. It's better on all kinds of levels. It's better for you to estimate more material, more money in it. If you still make the jobs to a point, it's not good to start throwing bad numbers and getting gigantic numbers that don't relate to reality, because then you can get yourself out of a job. But just by rounding up and adding here and there, it's just better to have some fat for it. Better to have more than less. So never give yourself less.
So can you get a half a yard of concrete? So you would go
Quarter of
1.5
a yard too, yeah.
Okay.
Yeah, our pour was 1.57 yards.
Okay.
And I ordered, or actually maybe it came out to 1.7. I was going to get 1 3/4 yards, and then Jim said just get 2. So. And then you saw what we had left over.
John, did you see, were you
I
there?
don't, no, I'm not.
Oh, yeah, you didn't see, but if you see the video, you haven't seen the video yet?
No,
Oh, you haven't seen the video because you don't,
I'm
you're not in
in
that
one time,
class.
yeah.
We poured a second pad with the
Okay.
extra.
Yeah, we had another, we quickly formed up and poured another step. I got rid of a couple of wheelbarrows full, and then we just divvied up a bunch of piles, and that's a thing that you all want to remember is when you have too much concrete, like it's in a wheelbarrow, the guy's gone, and usually that's where you'll put it in a wheelbarrow. If it's in a wheelbarrow or wherever it's put, make the concrete into small enough piles, like about a foot by a foot by a foot, that you can pick the damn things up. Or you'll do things that you'll learn the hard way, like I have, and you have a big pile of concrete, and then when you go to throw it out, you have to get out a jackhammer because you can't lift it. Nobody can.
Right.
You have to bust it up in manageable pieces. So make it into manageable pieces while it's still like Play-Doh, and then makes it a lot easier. Concrete estimation. The process of pouring a patio slab. First, the edges of the forms are set. A 6-inch sub base of gravel is placed at the edge of forms before concrete can be ordered for delivery. To calculate how many cubic feet of gravel fill is needed, the volume is first calculated. So 6 times 8 is 48. And it's a 6-inch sub base, so that's half of a foot, right? So that's going to be 24 cubic feet. I'm sorry, 24 cubic yards, right? Yeah, it's going to be 24 cubic yards, but that needs to be done in cubic feet. So to get 24 cubic yards into cubic feet, you need to divide 27. I think that's it, right? Well, let's just follow their thing here. So volume is length times width and height. So that should be 8 yards times 6 times half, should be 48, right? 8 times 6 is 48, and half of that, I'm sorry, it should be 24. What am I saying here? And then 8 yards, okay, I see. 8 yards times 6 yards times 0.066 of a yard, because that of a cubic yard, right? That must be a cubic yard. Yeah, it must be of a cubic yard, because 6 inches is 0.166 of a yard. 6 inches of a foot. I'm so confused right now. Somebody help me. The volume is then converted to feet. So to get this, we did length times width. That's obvious. 6 times 8, right? Times height. And the height, I guess, is 6 inches.
Yeah, it's 6 inches is 0.166
Of a yard. And to get that, you would do what, 6 over 36, 36 divided by 6 divided by 36, isn't that right? 6 divided by 36 equals, yeah. So to get that, to find out how much 6 inches is decimal wise of a yard, you take 6 into 36, because there's 36, right? You put 6 inches over 36. So it's 6/36 of a yard. And then to find out the decimal equivalent, take the bottom number, divide it into the top number. So 36 divided into 6 gives you that 0.166. So 8 times 6 times 0.0 gives you 7.99, round up to 8 cubic yards. 8 cubic yards, you'd have to do that times 27 to get 216 cubic feet of gravel. Gravel sold by the yard too, so. But somebody would say, well, how many cubic feet you want? Well, if you know the cubic yards, just multiply it times 27, and you'll have the cubic feet. So again, if you know the numbers to put in there, you're going to get it right every time, because you're going to be using your calculator. In most of the stuff I do in my head, I'm willing to do it like that. But if there's money involved, I'll do it in my head, but I'm going to write it down, and I'm going to use a calculator, because I'll make plenty of mistakes in my head, but I rarely make mistakes on calculator. And something I've told you about, I almost never make mistakes because I run a tape in my calculator. I always, when I'm done doing numbers, I look at my tape. I make sure that I pressed in all those things, and they came out on tape. Not just counting on my fingers did the right thing. Workspace, wait, that was it? That's it? We're done? No. All right, so does anybody want to go to board feet? Oh, and we're gonna go through this. We're gonna go through this. Okay, yeah, that'll be perfect. And then we'll get out of here a little early. Okay, so let's figure out the volume here. So a cube with 7-inch sides. It's gonna be 7 times 7 times 7, right? So 7 times 7 is 49 times 7. Again, you're just gonna press your calculator. What do you got, Ben?
Sorry, I'm slow. 49 times 7, 343.
343? Let's see. Volume measurement. 343. You're right. Easy peasy, right? A cube with 4 foot 6-inch sides. That's just plugging into your calculator. 4.5 times 4.5 times 4.5. That's the answer. And anybody have any questions about 6 inches being 0.5 of a foot? Easy, right? What's the decimal equivalent of 3 inches?
0.25.
What's the decimal equivalent of 9 inches?
0.75.
8 inches.
0.666.
Pretty popular.
I'm on some group text with my wife and kids and all this stuff. It's annoying.
The answer to this came out to 91.125.
91.125 that cube?
Yeah. Do you know what that would come out to? In inches?
Yeah, so well, that's good, Luke. So let me do this with you. 4.5 times 4.5 times 4.5 equals 91.125, which is 91, and that's an eighth, right? So an eighth of so to convert that to inches is just how do I convert that to inches?
Multiply the 0.125 by 12.
Yeah, that's it.
Is that
Is that it? Yeah, that's it. That's it.
1.5 inches?
Times 12 equals. No, that's not it. That's not it. Oh, wait. 0.125, is that what it came out? No, that's not right.
Yeah.
So-
0.125.
Let's back up a second. Let's get this straight. I'm getting tired.
Yeah.
Duh. Okay, I want to do this. I want to do this again. So 4.5, we all agree that 4 foot 6 is 4.5, right? Times 4.5 times 4.5 equals 91.125. And that's the thing. That's feet. And you want to know what an eighth, right? Because 0.125 is an eighth. You want to know what an eighth of a foot is? You do 0.125. God damn it. You do 0.125 times 12. 1.5. It's 1.5 inches. Lou. An eighth of a foot is 1.5 inches.
Got it.
Because 8 times 1.5 is 12, right? 8 times 1 is 8. 8 times 5 is 0.5 is 4. It's 12. Okay, a cube with 12 foot 3-inch sides. It's 12.25 times 12.25 times 12.25. That's your answer. Now, what does that come out to? You want to ask me how many inches that is? I bet you do. 12.25 times 12.25 times 12.25 equals 1,838.265625. 265625. 26.265625. Oops. 0.26.
What is it?
25.
0.2625.
Point two six,
times
point two six.
It's 3 inches, I guess, something like that.
Yeah.
Anyway, just,
764.
yeah, that's fine, whatever. Did you look the equivalent in the back? Yeah, well, that's good. Really, however you can, at this point, seriously, however you can find the answer. No, I'm serious. However you can find the answer, finding on your calculator or find the decimal equivalent in a fractional inch there. That's a good idea. I mean, use those tools. I told you to take pictures of those pages. Pull them up on your phone if you don't have that ass book with you.
So for instance, Mr. Rodney,
Yes.
like number 3 that we were discussing for
Yes.
the 0.26562 is 17/64.
Yes. Is that right?
Yes, it's correct, but how would you write the cubic part or the units?
Well, you'd write it in feet, the way it came out of the calculator,
So with decimals?
with the decimal.
Oh, okay.
The only way you're gonna do it, well, I take it back, No, you would convert back to inches. You'd convert. So in other words, it starts with inches, 12 foot, 3 inches. You want to know what the denominator is inches. So it needs to be cubic inches. So you need to change that decimal to inches. You need to take that decimal and do it times 12 and make it into inches, just like we just said.
And just how, would you just write how the answer would look
Yeah,
on the board
yeah,
for me, please?
I will. Let me do it again.
Well, I have the answer here if you want.
No, I want to do it. I want to get myself back on the ball. It's 1838.2, it's 265625, right?
Uh-huh.
So 265625. So
That is square feet, right? Pardon me.
yeah, that's square feet, but then we need to find out, so it's 1838, no, it's cubic feet,
Cubic,
not square
cubic,
feet.
uh-huh.
Cubic says, so 1838 cubic feet, and you know what? No, it's not gonna be inches. It's not gonna be cubic inches. It's all cubic feet. So I'm sorry if I confused anybody there. When you're cubing something at 12 foot 3 inches, you're coming up, it's only one thing, it can only be one thing. So the one thing would be cubic feet, and that's 1838 point blah, 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 2656 cubic feet.
And
Now
that's
you could change that into cubic inches or cubic yards if you wanted to.
but the entire thing, not just
But the answer to that is cubic feet. It has to be a decimal. There are no inches involved. Once you get into the cube, whatever denominator you come up with, that's what you got to stick with. Did you understand that, Dylan? I don't think you did. Did you? No.
Yeah, he's got it.
Explain it to me. Never mind. Here's this
How
guy.
much longer do you want to be?
Okay, fine. Come on, let's get through this. Let's get through this. Rectangular solid, 16 inches by 4 inches by 2 inches. So this is we're gonna probably want cubic inches, right?
Uh-huh.
So it's, again, simply, we're gonna use our calculator. I'm gonna go 16 times 4 equals times 2 equals 128 cubic inches. Now, we know that there's 1768 cubic inches per cubic foot. So if you needed to know what the cubic foot was, you divide that into it. But that seems like they're looking for cubic inches in this answer here. The rectangular solid 48 by 10 by 3/4. Now that one's a little different because you're going to go 48 times 10 times 0.75, right? Because 3/4 of an inch is 0.75 of an inch, right? And that equals 360. Did you just, oh, you just looked at me. You're not doing yourself any favors. That's okay.
10 bags over here.
Rectangular solid 5'3" by 1'9" by 6 inches. You understand that you have to multiply 5.25 times 1.75 times 0.5, correct? And that will give you your answer in cubic inches. You have to convert those to decimals. All those inches have to be converted to decimals before you can multiply them, unless you've got one of these cheating ass calculators. Well, you might ask yourself, what's an ass calculator? Well, ask me later.
You go like an ass book.
So,
How do you order
a
stock?
lot like an ass book, yeah.
Yeah. How do you order stock?
How do you order what?
How do you order sod? Like you were talking about.
Sod?
Yeah.
Oh, is one of these questions about sod?
It's in rolls, isn't it?
Yeah, it's rolls. It's rolls, but it covers square feet, not cubic feet. So in a lawn area, you don't care about cubic feet, not like gravel or filling up with dirt. It's totally square feet, and a roll of sod will cover X amount of square feet. And what you probably find out is, is like, how wide is it? If you're gonna roll them that way, now are they in 2-foot rolls? And if it's 36 wide, you're gonna need 18. That'd be an area thing. All right, so you just gotta make this into decimal feet. Decimal feet. 0.25, 3.5, and 48 feet all together. That'll give you the number of cubic feet in a room. 8 foot by 11 foot 8 by 13.9. Again, 8 foot times 11.66 or 67 times 13.75. And you're going to have a cubic foot number. How many cubic yards of concrete are needed for 4 slabs? Measuring 4 inches thick, 8 foot wide, 10 foot 6 long. Piece of cake, right? Well, let's find out how much one of them is. And one is 8 times 10, 6. 8 times 10.5 times 0.333 equals times 4 equals. So that's how many cubic feet, right? Right there. Yeah. And
Well,
then,
cubic
and
yards,
then,
right?
and I'm sorry, and then divided by 27. Okay, so that's 4.144 cubic yards. So that to do that, again, the sequence of doing it, just pressing the right numbers, you're gonna be fine. You need to figure what one slab is, which is 8 times 10.5 times a third, or 0.333. That gives you one slab. There's 4 of them. So that answer times 4 gives you how many 4 slabs are in cubic feet. Now you need to divide that by 27 cubic yards. And that'll give you your yards. And that's how much concrete, and we're with a little bit of a fudge factor. How many cubic yards of earth must be removed to install an in-ground swimming pool measuring 8 by 12 by 18? Well, 8 times 12 times 18 divided by 27, right? 8 times 12 times 18 divided by 27 equals 64 yards. Right? It's easy. It's easy. Seriously, it's seriously easy. So 11 through 15, you know what? Does anybody have any questions about how to do this? Anybody? Everybody know how we achieve, how we get cubics measurement, how we get volume, how we figure volume, and how to turn that volume into cubic yards and stuff like that, because you need to know how to do it, especially how to turn area into square yards and square feet, and how to turn it into cubic yards. So yes, everybody knows it. Everybody at home knows it. Everybody shaking their head. Michael, Matthias, Jose, Brandon, Joel, Zach, shaking your head. Yeah, everybody good? Okay, see you next week.
Hey,
Yeah.
Yes.
did you take roll?
I did take roll. Yeah, no, I took roll. That's good. That's good. Hey, but did Matthew make it? Or Adair? No, I did take. Did I? Hey, you guys, it's been a pleasure.
Thank you, Rodney.
Way to go, Austin, on figuring that out. Good job. Jose, Zach, see you all next week. Hey, see some of you next Tuesday. Later.